all my dear students. Today we are going to take the very first chapter of your textbook, that is rational number. This is the introductory video in which I will tell you what are rational numbers. But before coming up to the topic, we will discuss few terms which you have already learned in class 6 and 7. First term is natural numbers, 1, 2, 3, 4 up to n numbers. These numbers fall in the category of natural number. Second term is whole numbers. Whole numbers 0, 1, 2, 3 up to n numbers. All these numbers fall in the category of whole numbers. Integers -1, -2, 0, 1, 2 up to n numbers. All such type of numbers fall in the category of integers. That is, integers are both positive as well as negative. These were the terms which we have discussed. Now let us come to rational numbers. What are rational numbers? Rational numbers in simple language, students, is the numbers which can be written in the form of p by q, and here both p and q are integers and q must not be equals to 0. Let us make the picture more clear with the help of few examples. The very first example is 2 upon 9. 2 upon 9, it is in the form of fraction and it is in the form of p by q. Here p is 2 and q is 9. Both are integers and q is not equals to 0. That's why it is a rational number. Now, can we say that 6 is a rational number? Yes, we can say that 6 is a rational number because below 6 I can write 1. As you can see, I have already written. So it is in the form of p by q and q is not equals to 0. The third example is -4 upon 5. Here p is -4 and q is 5. -4 is also an integer and 5 is also an integer, and both are in the form of p by q and q is not equals to 0. That's why -4 upon 5 is also an integer. Yes, now the next question that arises in my mind is 0 an integer? Yes, 0 is integer, you all know. Then the next question that arises, is 0 a rational number? Yes, of course students, 0 is also a rational number because we can express 0 in the form of p by q, and here q is not equals to 0. Below 0 I can write 1 in the denominator. That's why 0 is also a rational number. I hope you have learnt about rational numbers and the picture of rational number is clear in your mind. I repeat, rational numbers are those numbers which can be expressed in the form of p by q, and p and q both are integers and q must not be equals to 0. About properties of rational number. So our first property is closure property. Let us see what closure property says. In closure property, we will see closure property in case of addition, subtraction, multiplication, and then in division. Let us see in case of addition. As you can see here, in addition, the condition is that a upon c plus c upon d is a rational number, then the answer must be a rational number. Let us see one example. 6 upon 9 is a rational number, plus 2 upon 9, it is also a rational number. As the denominators are same, so we can add the numerator. 6 plus 2 gives 8 and the answer is 8 upon 9. A upon b was also a rational number, c upon d was also a rational number, and the ultimate answer that we got is also a rational number. Therefore, the closure property is applicable in case of addition. Let's see in case of subtraction. A upon b minus c upon d is equals to a rational number. We will see this with the help of example. 3 upon 5. In second example, 3 upon 5 minus 1 upon 5 the denominators are same, so we can easily minus the numerators. That's why 3 minus 1 gives you 2. Hence your answer is 2 upon 5. It means that 3 upon 5 was a rational number, 1 upon 5 was a rational number, and the answer that we got is also a rational number. Therefore, we can say that closure property is applicable in case of subtraction. Now we will see in case of multiplication, A upon B into C upon D, the answer must be a rational number. Let us check with the help of example. 6 upon 4 into 2 upon 3. 6 upon 4 is a rational number and 2 upon 3 is also a rational number. So the product, by doing the product, what we get, 6 into 2 is equals to 12 and 4 into 3 is equals to 12. When both numerator and denominator are same, we can cut and the answer is 1. And in the previous video I told you that 1 is also a rational number. Hence we can say that closure property is applicable in case of multiplication. Now let us check in case of division. A upon B divided by C upon D, the answer must be rational number. See the following example. Minus 5 upon 3 divided by 2 upon 5. I hope you all know how to solve this type of question. You get the answer minus 25 upon 6. But student, in closure property, the condition is that C upon D must not be equals to 0. If C upon D is equals to 0, then the closure property will not work in case of division. Hence we can say sometimes closure property is applicable in division, but sometimes it is not applicable. So we can say that closure property is applicable in case of addition, subtraction and multiplication, but not full-fledged in case of division. I hope the closure property is clear to all of you. Now we will see the next property. So the next property is commutative property. We will see commutative property is applicable in which cases. First is addition. According to commutative property, in case of whole numbers, A plus B must be equals to B plus A. It means that LHS must be equals to RHS. A plus B and then reverse B plus A. When we will add, in both the cases the answer must be equal. If the answer is equal, then it is applicable in case of addition. Here we are looking in case of rational numbers. In case of rational numbers, A upon B plus C upon D must be equals to C upon D plus A upon B. Let us see with the help of example. 2 upon 5 plus 4 upon 5, it is on LHS side, and 4 upon 5 plus 2 upon 5 is on RHS side. By solving LHS and RHS, we get the answer 6 upon 5. Both LHS and RHS are equal. That's why commutative property is applicable in case of addition. Let us check in case of subtraction. In case of subtraction, A upon B minus C upon D is equals to C upon D minus A upon B. Let us see with the help of example. 1 upon 5 minus 3 upon 5 must be equals to 3 upon 5 minus 1 upon 5. But when you will solve the LHS side, you will get minus 2 upon 5, and in RHS side you will get 2 upon 5. It means that LHS is not equals to RHS. Therefore, commutative property is not applicable in case of subtraction. Now the next comes in case of multiplication. A upon B into C upon D is equals to C upon D into A upon B. Let us see with the help of example. 1 upon 4 into 2 upon 3 must be equals to 2 upon 3 into 1 upon 4. When we solve RHS and LHS side, we get the answer 2 upon 12. So LHS is equals to RHS. That's why commutative property is applicable in case of multiplication. Now let us check in case of division. In case of division, A upon B divided by C upon D must be equal to C upon D divided by A upon B. Let us see with the help of example. 6 upon 4 divided by 2 upon 3 must be equals to 2 upon 3 divided by 6 upon 4. In previous classes you have learned how to solve such type of equations, such type of questions. So when you will solve, you will get that RHS is not equals to LHS. It means that commutative property is not applicable in case of division. I hope the things are clear to you. I repeat again that commutative property is applicable in case of addition and multiplication, but it is not applicable in case of subtraction and division. You can take more examples and check whether it is applicable or not. Thank you.